So we're looking at question 31 for the MAC 1140 Pre-Calculus Final Exam Review. It states to use properties of logarithms to expand the logarithmic expression, where possible, evaluate logarithmic expression. So we're given that the log base b of the argument x y squared divided by z to the fifth power. So recalling your quotient property, we already see that this has division. And your quotient property has that whenever there's division involved, you have a subtraction sign in between the numerator and the denominator when you break it down into terms. So when I say this, I mean that we're going to break our numerator and denominator down into different terms, two separate terms. So we're going to have log base b of our numerator, which is xy squared, minus, because it's, again, your quotient property. And you're going to have log, keep that same base of b because it's applied to your entire term. And then your denominator, which is z to the power of 5. Now, we have that broken down, but we can see, again, that we have multiplication going on in our first term. So we can break that down even further. We know that for our product property, it's always going to be addition. So for a product property, it's typically your first variable plus your second variable. So what I mean by that is we're going to have x plus y squared as two separate logarithmic terms. So when you rewrite that, you're going to get log, keep the same base, of x plus, because it's your product property, log base b of y squared, and then bring down your second term from the first step, and you're going to get minus log base b of z to the fifth power. Now, we have another property that we can evaluate and use. So this one's going to be your power property because we have exponents. We know that using the power property, we can bring those out in front of our logarithmic terms. So when we do that, we will be getting log base b of x plus, bring that 2 out, 2 times the logarithm of base b of y minus, bring that 5 down, 5 times the logarithm of b of z. And that is your fully expanded logarithmic expression.